Hello students, how are you? Okay, let's start the chapter work, energy and power. What do you mean by work? Work is said to be done whenever a force acts on a body and the body moves through some distance in the direction of the force. If the force F makes an angle theta with the direction of the displacement S, then the work done W equal to vector F dot vector S, and that will be equal to Fs cos theta. Work is a scalar quantity. It can be positive or negative depending on theta is acute or obtuse. The work done by the friction or viscous force on a moving body is negative because the frictional force always opposes the motion of the body. Work done is a scalar quantity. If theta is 0 degree, then W is Fs, meaning that work done is maximum. If theta is 90 degree, then work done is 0. Work done will be 0. Work done against a variable force. The work done by a variable force F in changing the displacement S1 to S2, W equal to integral over S1 to S2 F dot ds. Work done in terms of rectangular components. Vector F equal to Fxi plus Fyz plus Fzk. S equal to Sxi plus Syj plus Szk. Then W equal to Fx Sx plus Fy Sy plus Fz Sj. Newton's third law and the work done. For two bodies, the sum of the mutual forces exerted between the two bodies is zero from Newton's third law. Vector F12 plus vector F21 equal to 0. But the sum of the work done by the two forces need not always cancel. F12 plus F21 not equal to 0. Energy. What is energy? It is defined as the ability of a body to do work. It is measured by the amount of work done that a body can do. It is a scalar quantity. Like work, SI unit of the energy is also joule. And in CGS system, its unit is erg. The unit of energy used at atomic level is electron volt eV. 1 electron volt equal to 1.6 into 10 to the power minus 19 joule, and 1 million volt electron volt equal to 10 to the power 6 electron volt, and it will be equal to 1.6 into 10 to the power minus 13 joule. Now the kinetic energy. What is kinetic energy? It is the energy possessed by a body by the virtue of its motion. It is the energy possessed by a body by virtue of its motion. The kinetic energy of a body of mass m moving with velocity v equal to k equal to half mv square. In work energy theorem. What is work energy theorem? The work done by the net force acting on a body is equal to the change in the kinetic energy of the body. W equal to kinetic energy, change in kinetic energy, and it will be half mv square minus half mu square. The work done, the work energy theorem may be regarded as the scalar form of Newton's second law of motion. The work energy theorem may be regarded as the scalar form of the Newton's second law of motion. Now the potential energy. What is potential energy? It is the energy possessed by a body by the virtue of its position. For a conservative force in one dimension, the potential energy will be equal to minus dux upon dx, or it can be written delta u equal to uf minus ui. Gravitational potential energy. What is gravitational potential energy? It is the energy possessed by a body by virtue of its position above the surface of the earth. Once again, I am repeating the statement. It is the energy possessed by a body by virtue of its position above the surface of earth. The gravitational potential energy of a body of mass m at height h above the Earth's surface is U equal to mgh. Potential energy of a spring. According to Hooke's law, when a spring is stretched through a distance x, the restoring force set up in the spring due to its elasticity such that F is directly proportional to x, that it will be F equal to minus kf. Here k is the force constant or spring constant. It is the restoring force set up in the spring per unit extension. Its unit is Newton per meter. The work done is in the work done in stretching the spring through the distance x will be W equal to from integration from 0 to x kx dx, and it will be half kx square. Conservative force. What is conservative force? A force is conservative. Number one, if the work done by the force is displacing a particle from one point to another is independent of the path followed by the particle. I am repeating once again. If the work done by the force is displacing a particle from one point to another is independent of the path followed by the particle. Number two is if the work done by the force in moving a particle around a closed path is zero. Gravitational force, electrostatic force, and elastic force of a string of a spring are all conservative forces. Now, non-conservative forces. What are non-conservative forces? If the amount of work done in moving an object against a force from one point to another depends on the path along which the body moves, then such a force is called a non-conservative force. Forces of friction and viscosity are non-conservative forces. Mass energy equivalence. According to Einstein, mass can be converted into energy and energy can be converted into mass. A mass m is equivalent to energy and it is given by equal to mc square. C is the speed of light in vacuum and c will be equal to 3 into 10 to power and c will be equal to 3 into 10 to power 8 meter per second. Now the power. What is power? The rate of work done is called the power. SI unit of power is watt. Power equal to work upon time. P equal to W upon T. Law of conservation of energy. Law of conservation of energy. It states that energy can neither be created nor be destroyed, but can only be transferred from one to another. Collision. What is collision? A collision between two bodies is said to occur if either they physically collide against each other or the path of the motion of one body is influenced by the other. Elastic collision. If there is no loss of kinetic energy during collision, it is called an elastic collision. Inelastic collision. If there is a loss of kinetic energy during a collision, it is called an inelastic collision. Linear momentum is conserved in both elastic and inelastic collision. Linear momentum is conserved in both elastic and inelastic collisions. Perfectly inelastic collision. It is the collision in which two bodies stick together after the collision. Head-on collision or one-dimensional collision. Head-on collision or one-dimensional collision. It is a collision in which the colliding bodies move along the same straight line before and after the collision. It is the collision in which the colliding bodies move along the same straight line before and after the collision. Oblique collision. What is oblique collision? If the two bodies do not move along the same straight line before and after the collision. The collision is said to be an oblique collision. Velocities in one-dimensional elastic collision. Suppose two bodies of masses m1 and m2 moving with velocities u1 and u2 in the same direction suffer head-on collision. Let v1 and v2 be the velocities after collision. Then by the law of conservation of momentum, m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. And the kinetic energy conserved in an elastic collision, half m1 u1 square plus half m2 u2 square equal to half m1 v1 square plus half m2 v2 square. Velocity of approach equal to velocity of separation. u1 minus u2 equal to v2 minus v1. And v1 can be written as m1 minus m2 upon m1 plus m2 into u1 plus 2m2 upon m1 plus m2 into u2. And v2 equal to m2 minus m1 upon m1 plus m2 into u2 plus 2m1 upon m1 plus m2 into. If you have liked my video, please like and subscribe my channel. Thank you.